We have all seen this happen. A multi-agent system runs flawlessly in local testing. It researches, writes, and analyzes exactly as designed. Then you push it to production. Within 48 hours, the data analyst is trying to write CEO memos and the entire pipeline crashes. The breakdown happens when we try to cram an agent's identity, its available tools, and its behavioral rules into a single massive system prompt. Over a long context window, the model loses track. It forgets its specific job description. We can fix this by completely abandoning the giant prompt. Instead, we split the instructions into 4 distinct markdown files that act as rigid, unignorable boundaries. Look at this contractor hiring analogy diagram. You don't hand a new hire one disorganized manual. You give them a specific role, their resume. You verify their exact capabilities, their skins, and you provide a handbook detailing how to behave on the job. By isolating these components, the agent cannot accidentally blur its instructions. This modular separation is what stops rogue behavior and allows a local prototype to scale reliably into an enterprise system. To build this structure, open your repository root. Create a new file named agents.md, plural. This file acts as the city map for your codebase. It documents the entire multi-agent ecosystem and establishes the organizational chart so every piece knows how to connect. This section illustrates the setup. You must sharply define boundaries so an orchestrator knows exactly which specialist to hand a task to next. By specifying strict inputs and outputs, you lock agents into designated domains. The writer literally cannot accept raw data meant for the analyst. Step 2 is giving each individual agent its badge. Create a dedicated folder for one specific agent, and inside, generate a singular agent.md file. This file is just an ID badge, like the one shown here. It rarely means to exceed 30 lines. It exists solely to tell the agent exactly who it is. For example, I am the data analyst. Developers often skip this file because it feels administrative. They assume the agent inherently knows its role because of the tools it was given. Every time a new conversation starts, the agent begins with 0 memory. Without an identity file, it guesses its job based on tools, ensuring hallucinations. Inside that same agent's folder, create a skills directory. Inside that, add a skill.md file. A skill file cannot be a simple description of what the agent can do. It must be highly prescriptive, acting as a direct training manual for task execution. Here, you write a mini standard operating procedure. Embed real Python libraries and code logic directly, so the agent doesn't guess how to format requests. You also explicitly write out failure modes. When an API errors, the agent reads this to know exactly how to recover. Drop back into the main agent folder and create the final document, the instructions.md handbook. This is the agent's behavioral guide. As shown in the green section, structure this using numbered workflows the agent reads top to bottom. Keep core constraints isolated, separating what it must always do from what it must never do, and explicitly dictate its output tone. When a pipeline breaks because an agent gets too creative, don't rewrite the entire prompt. Check this single file to pinpoint where the guardrails failed. Your repository now has an explicit map of the system, a clear identity for every agent, a daily routine, and a job manual. The entire ecosystem is highly legible to both your human code reviewers and your AI orchestrators. Before you deploy this architecture, run it through a final verification phase. First, confirm each skill file contains only one specific capability. Second, verify every agent has explicit handoff targets defined. And third, ensure your instructions force the agent to return structured JSON. Structuring repositories like this is one piece of a much larger shift. The industry is moving past basic API wrappers and demanding full agentic systems. This roadmap outlines the path. Step 1, master foundations like asynchronous Python and prompt engineering. Step 2, build retrieval augmented generation pipelines. Step 3, introduce agency using the reason and act pattern. Finally, Step 4 hardens the system using LLM as a judge observability. Implementing strict modular boundaries is the dividing line between building fragile toy applications and engineering resilient enterprise-grade AI.